Want to efficiently analyze data in Python? Then you need to learn Pandas. This library is essential for anyone working with data, and in this video, we'll cover the fundamental building blocks, series and data frames, along with basic operations. Let's get started. We'll be using Jupyter Notebook, an interactive environment ideal for data exploration. We'll install Pandas, introduce series and data frames, and demonstrate core operations. By the end, you'll have a solid foundation to begin working with Pandas for your own data projects. First, let's ensure Pandas is installed. We'll use pip, Python's package installer. Open a new cell in your Jupyter Notebook and type !pip install pandas. This command, !pip install pandas, will download and install the pandas library. The exclamation mark tells Jupyter to run this as a system command. Execute the cell using Shift plus Enter. You'll see installation progress. If pandas is already installed, it will indicate requirement already satisfied. Now, to use pandas in our notebook, we need to import it. In a new cell, type import pandas as PD. This line imports the pandas library and assigns it the conventional alias PD. Using PD as an alias is standard practice and makes your code more readable. Pandas revolves around two key data structures, series and data frames. We'll start with series. A Pandas series is a one-dimensional labeled array. Think of it as a single column of data with an associated index. This index provides labels for each data point. Let's add a comment, number, creating a Pandas series, and import numpy as it's frequently used with pandas. Import numpy as mpz. Numpy is a powerful library for numerical operations in Python and often complements pandas. To create a series, type my series equals pd.series open bracket 10, 20, 30, 40, 50 close bracket. pd.series is the constructor function for creating a series. We're passing a Python list 10, 20, 30, 40, 50 as the data. Execute this cell, then in the next cell, type my series and run it. This is our Pandas series. On the left, 0, 1, 2, 3, 4 is the index, automatically generated by Pandas starting from 0. On the right, 10, 20, 30, 40, 50 are the values. D-type. Int64 indicates the data type is 64-bit integers. Series can also be created from dictionaries. Add a comment, #series from a dictionary. Then type my_series.dict equals pd_series open curly, quote a colon 100 comma, b colon 200 comma, c colon 300 close curly quote. Here, we use a Python dictionary. Run and print my series dictionary. Now, the index is A, B, C, taken from the dictionary keys. The values are 100, 200, 300 from the dictionary values. Dictionaries allow you to define custom index labels. Let's look at basic operations with series. Section for operations. #basic series operations. First, accessing elements. Comment, #accessing elements. To get the first element of my.series, value 10, use its index 0. Type my.series 0 and run. Output is 10. Element access is done using square brackets and the index. Python uses zero-based indexing. For my.seriesDict, to get the value for index b, type my.seriesDict open bracket b close bracket and run. Output 200. With custom labels, you access elements using those labels within the square brackets. Slicing allows you to extract a range of elements. Comment, #slicing series. Type my series 1 to 4 and run. Output is a series with indices 1, 2, 3 and corresponding values. 1 to 4 specifies a slice from index 1 up to, but not including, index 4. Series support element-wise arithmetic. Comment, #basic arithmetic operations. Type my series *2 and run. The series values are multiplied by 2. Pandas applies the operation to each element in the series. Addition, subtraction, division, and other operations work similarly. Now let's move to data frames. Data frames are the workhorses of Pandas for tabular data. A data frame is a two-dimensional labeled data structure, essentially a table with rows and columns. Each column in a data frame is a series. Section. Write hashtag creating a Pandas data frame in the markdown cell. Now method. Hashtag from a dictionary of lists. Define a dictionary data. Data, she, name, Alice, Bob, Charlie, age, 25, 30, 22, city, New York, London, Paris. Keys are column names, values are lists of column data. Create a data frame using pd.dataframe function. df equals pd.dataframe data. Run and print df. This is a data frame. Columns, name, age, city are from the dictionary keys. Rows are indexed 0, 1, 2. Each column is a Pandas series. Let's explore basic data frame operations. Section. Type hashtag basic data frame operations in the markdown cell. Accessing columns. Type hashtag accessing columns. To get the name column, type df left bracket name right bracket and run. Output is the name column as a Pandas series. To access multiple columns, use a list of column names. df open bracket name, comma city close bracket and run. This returns a new data frame with only the specified columns. Accessing rows uses .alloc, label based, and .iloc, integer based. Comment. Hashtag accessing rows, using .loc and .iloc. Hashtag .loc, label based. Get the first row using df.loc open bracket, 0 close bracket, and run. Output is the first row as a series, indexed by column names. .loc uses index labels for row access. For integer-based row access, use .iloc. Comment. Hashtag period eloc, integer based. Type df.eloc open bracket, 0 close bracket and run. Output is the same in this case as row labels are numerical. eloc uses integer positions for row access. Data frame slicing. Comment. Hashtag slicing data frames. Slice the first two rows, df open bracket 0 colon, 2 close bracket and run. Output is the first two rows. Data frame slicing, by default, operates on rows. Adding a column. Comment. Hashtag adding a new column. Add a country column, df country, takes USA, UK, France, and run. Print df. The country column is added. Assigning a list to a new column name creates a new column in the data frame. We've covered the basics of Pandas series and DataFrames, including creation and core operations. This provides a fundamental understanding for working with data in Python. This introduction provides a starting point for using Pandas. Practice these operations in Jupyter Notebook to solidify your understanding. Pandas offers extensive capabilities for data manipulation and analysis. To test your new Pandas skills, here's a challenge for you. Create a Pandas series named Temperatures from the Python list 22, 25, 21, 28, 24, representing daily temperatures in Celsius. Then convert these temperatures to Fahrenheit and store them in a new series called Fahrenheit temperatures. Remember the formula. Fahrenheit equals Celsius, multiply 9 divide by 5 plus 32. Share your code in the comments below. Let's see who can crack this temperature conversion challenge using Pandas. If you found this helpful, please like and subscribe for more data science content. Let me know in the comments what Pandas topics you'd like to see covered in future videos, such as data cleaning or more advanced operations. Thanks for watching and happy data exploring.